Hello, it's me, and I'm going to ask the age-old question of what happens when you take normal cubes and you give them superpowers. You end up with supercubes. So what is a supercube and what endows them with special, extra powerful features? Well, starting off with this, since 3x3s are the more classic things, we'll bring its brethren out here, is, as you know, you've got specificity with center rotation. Now before I had equivalency of rotation, what I call rotational equivalencies of the centers. What that means is if I were to take a Rubik's Cube, just 3x3, and I do this, R, U, R, I, U, 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 R, U, R, I, U. Well, I did that until it came all the way back to the beginning, and there's really no difference, right? This is still in a solid state. But let's do the same thing with this puzzle. So notice with the Supercube, I've got this white stripe by the white side, pointing to the white side, rather the brown stripe pointing to the brown side, yellow and yellow, and you'll find that all the way around. But let's do that same thing. R, U, R, I, U, R, U, R, I, U. And we're going to keep doing that simple pattern. And you can see I'm once again back to the beginning, but something's very different. This yellow stripe is now pointing to the white side, and this white stripe is pointing to the yellow side. In essence, this is how you rotate a center by 180 degrees. Just keep doing RU, 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 RU. So in so doing, it shows really in essence the basic difference between the puzzles. This one has many different solid states. This solid state is the same as a solid state as if this were rotated 180 degrees, or if this were rotated 90 degrees and this were rotated 90 degrees. So in essence you have equivalency of rotation, rotational equivalency. Here you don't. You've got a specificity of rotation, which means that there is only one solid state. This one has, well, a lot more. You can calculate how much that is. But in essence, that's what lends to the challenge of this. We'll get this back here. So that brings us back to what we want. So there's different supercubes of different types of challenges. I've gone over much of these. I can point you to previous tutorials, but I want to highlight this guy over here. Now, it doesn't seem to do much good to talk about a 2x2 supercube because in essence, well, it has no centers and it has no edges. If it has no centers and edges, then really there's just corners, so there's always specificity of position. So if you look like at a 2x2, even if I were to put a blue stripe here and a yellow stripe here, it doesn't really matter because this piece has all colors on it anyway. As opposed to this piece, which only has one, and these pieces over here. So it's the center that gives you the specificity, but there's no centers in this. So this, in essence, is as much of a supercube as any of the others. So what happened when we put the center in here? Well, this isn't exactly a 2x2. It functions as a 2x2, but you've got the center over here that's moving along with it. And this lends it more of a degree of challenge. If I did the similar kind of stickers, it wouldn't change the challenge of the solve at all. So let's see what happens when we scramble this guy and what kind of challenges we have when we solve it. So as you can see with the centerpiece, you've got blue facing blue, yellow facing yellow, green facing green, and it's like that all the way around the puzzle. So we'll go ahead and scramble it. Now notice when I'm turning that, some pieces don't move the center and other turns do. So there's a little bit of a trickiness to this, but let's see where this is. Again, this was made by GR Cubed. He does all of my various iCubes and floppy iCubes, and his technique is just getting better and better. But I wanted to showcase this because there is a little bit of a dilemma in the process of this solve. Okay, so what do we think? Pretty good scramble? Pretty good scramble. So one thing to notice though is as I'm moving these pieces, when I move this, it's moving independent of the center. This one isn't. So there's something on this side that's bound or bandaged to the center. When I move this, this doesn't move, but this does. So it's one of these two pieces. One of these two pieces are attached to the center. Well, it's not this one. It must be this one. Because any piece that I don't move that isn't this, the center doesn't move. Anytime I move this piece around, it's attached. So what that means is that this piece here is attached to all these centers over here. So this side, this center, this top part, that's going to be the white side. It's going to follow this piece over here. This center, this is going to be the green side. It's going to follow this, and this will follow. This center will follow this side as well. And that makes sense because this white is pointing to here, this green is pointing to here, and this red is pointing to here. So in a way I can kind of cheat, because unlike any other 2x2 where you can make your center anywhere, you can make your side anywhere rather, here there's only one specific place. This has to guide where the centers are going to be, rather where the sides are going to be. So this has to be the green side following here, this has to be the red side, and this has to be the white side. So what does that mean in terms of the solve? Well, let's check it out. I'm going to keep this stationary, and I'm going to solve the rest around that. So this is going to be the green side, green and white, it's this. Now notice as I'm moving this, it's not changing my center position at all. Oop. And move it in, it's just positioning, so this is in here, and you can see this white is pointing to this white over here. So now the green, it'll be this green here, move this in, and we're doing fine. So yellow, now notice this green is not pointing up, so I have to coordinate that. So I'm going to move this down, move both of these down to the bottom, double turn, then I'm going to move this green down to the position it's supposed to be, double turn, and bring it up. So you'll find that doesn't really mess me up that much. Now the final green, now notice this green center is not properly oriented, it's supposed to be up here, so I'm just going to move that in now. Double turn, bring this down, double turn it up, so this is up here. And now I'm just going to move this guy in. Okay, so all of these are in. Now notice this one got flipped out, and the reason that it did is because I moved it in by this angle. So I've got to keep this stationary. So to make this happen, what I have to do is I'm going to move both of these down, bring this across, and bring it up. Okay, so green is up, green is up, green is up, green is up. Now where was my non-stationary side? It was this. My stationary side rather was this. So now I'm just going to solve it like any other 2x2. So we've got all these greens are facing down, which is good. Yellow, red, white, and orange. So I'm going to ignore the rest and I'm just going to put the blue in here. So I'm just going to do R-I, D-I, R-D, R-I, D-I, R-D, double turn, R-D, R-I, D-I, R-D, and we think everything's going fine, there's no surprises, and bang. Okay, so now this is up, this is in. We just have to flip these two, but when you look at this, this green is down, this is down, this is down, this is not down. This was pulled up. Now why did that happen? Well, the reason that that happened is because one of my moves was bringing the one that's bandaged to the center. I brought it up, moved it around, and that messed things up. So what I'm going to have to do is I'm going to have to get this back. So I'm going to move this down twice, double turn, move this in, double turn, and move it up. Okay, check our work, and we see everything is fine here. So now what I'm going to do is I'm simply going to do a corner swap. That's all I have to do right now, right? Corner swap, and that will be the end of this puzzle. So 2R, U, 2R, UI, 2R. Turn the puzzle 90 degrees, 2R, UI, 2R, U, 2R. And move this back. Okay, so when we do that, we see all these are lined up just fine, except now this is up, this green is up, and this green is up. So something went a little haywire with that. This was up and this is up. So how am I going to move these down without scrambling everything? Well, what can I do about this? Well, when I have a center, somewhere in the line of having a center means that there is some edges that might be hidden from here. Well, what happens, how can I move these centers? Both of these have to rotate by 90 degrees, so how am I going to do that? So, any thoughts? Well, let's take a look at some other supercubes and see what we can expect. I know that if I do edge swapping, it does turn the corners, or it does turn the centers as well. So what if I do an opposite edge swap? 2R to U, 2R to U, 2R to U. I'm not focusing on the edges, I'm more focusing on the centers. And you can see that it rotated this one up, so this got rotated. It was the only one that got rotated here, but this also got rotated. This white got rotated as well. So I know how to rotate this guy. 2R to U, 2R to U, 2R to U. Okay, so maybe if I do the same thing, I can get this green one down. 2R to U, 2R to U, 2R to U. And indeed, the green one is down. But this one was rotated up as well. Well, on first blush, we can say, okay, rotate this one down, which will rotate that one back up. So why don't I do that? And I will. So we'll go ahead and do the same thing here. 2R, 2U, 2R, 2U, 2R, 2U. Green is down, all the greens are down, and now this is fixed. So that's fine. So that actually worked out well with that. So that was the one of the various tricks that can happen with this particular puzzle. But that's not the only one. Sometimes you can have this. Okay, so you can see at first blush everything is looking fine. Green down, green down, green down, everything is fine. What I showed were two situations. What I showed was a situation where it didn't mess with the law of cubes, but now we have an issue here. This white one is facing the yellow, this yellow is facing the white, so this is basically rotated 90 degrees. So how do I get rid of this? Well, we know how to rotate a center 90 degrees, maybe I can do the same thing. Well, let's see what happens. I'm going to take my bandaged area, which is this one over here. And what I'm going to do is try the same thing. R, U, R, I, U, 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 and we keep going until it's done. And it works. So I did my rotation, make sure all is right with the world, and it's fine. So those are the various tricks that can happen with this. Sometimes you'll find two greens that are rotated up, with this one rotated 180 degrees, that's how I got out of that. Or if this is rotated by 180 degrees, then you can really do the same thing. So there you have it. Just want to do a demonstration on this really fun variation of 2x2s. Thanks for watching.